We are now going to examine composing functions. Okay, don't forget, composing means that we're going to plug a function into a function. All right, remember the nice notations I said I like to use? This says f of g of x. So what I'm going to do is write f of, and then I'm going to write g of x. So when you write it this way, g is the little function that's going into the big function. Okay, here's the rule for f, and here's the rule for g. So the second thing that you're going to do is you're going to write f of. And instead of writing the letters g of x, let's write down the g of x function right there. So 2x squared plus 3 is the g of x function. And that function, that quantity, needs to go into f. Now the best way to do this is to look at the f function and read him a couple of times out loud. So what does f say to do? F says, take your input, x is your input, square your input, and then add a 1. So take your input, square it, and add a 1. Okay, and this is my input. So what some people do is they kind of get ready. Take your input, square your input, and add a 1. That's what f says to do. And who's going into f? This g function. So I have to take 2x squared plus 3 and square him. I think the best thing to do here would be to write down 2x squared plus 3 2 times, just so we can see what we're dealing with. Don't forget to write plus 1. Every single line is equal. And I will do a couple steps here quickly. So first is 4x to the 4th. Outers makes 6x squared, and inners makes 6x squared for a total of 12x squared. And then the outers is plus 9. Oh, but plus 1 more makes 10. So this is f of g of x. Okay, let's take a look at the next one. After doing yesterday's lesson, I think it's pretty clear that f of g is not the same as g of f. So we're going to have to do a separate calculation over here. So we need to do g of, and then write f of x inside of it. This says g of f of x, and this says g of f of x. The second step is to write the letter g, write your big parentheses, but instead of writing the letters f of x, you write the f of x function in there. Put x squared plus 1 in the parentheses. So that quantity has to go into g. Let's go take a look at g, and I'm going to read him a couple times to see what he says. G says 2 times your input squared plus 3. 2 times the input squared plus 3. All right, let's go do that. Let's do 2 times the input squared plus 3. And what is the input? The input is x squared plus 1. Okay, maybe what I'll do again is write down x squared plus 1. I'll write that quantity 2 times, just so that I could do all the foiling nicely. I'm going to hang on to that 2. I'm going to distribute that in after I FOIL this out. First is x to the 4th. Outers and inners is 2x squared plus 1. Now you have to write plus 3. Don't forget to write the entire line. And this line of work equals 2x to the 4th plus 4x squared plus 2 plus 3 makes a 5. And this is g of f of x. Let's make sure we label all our answers so that people can tell that this g of f and that was f of g. And you can see how they're not the same. Okay, we're going to keep practicing plugging a function into a function. Here's one with some fractions, which of course is going to be way fun, right? So the first thing we do is we write this the nice way. F of g of x. Okay, the second thing that you do is you write f of, and you replace the letters g of x with his formula, which says negative 2 divided by x. Okay, now we're going to plug that quantity, that function, into the f function. Let's go see what f says. F says 1 divided by input plus 3. He says 1 divided by input plus 3. Okay, so let me write that. 1 divided by input plus 3. And what is the input? That function right there, negative 2 over x. Now we have to simplify this. You can't leave a triple-decker fraction. The first thing we have to do down here is add fractions. The denominator right here is a 1. So let's make common denominators by multiplying this one here by x over x. So now we have 1 divided by, the common denominator down there is x, and the numerator is negative 2 plus 3x. Now we cannot leave it like that. I'm going to show you a variety of techniques. One of the things that you can do, and some people like this from algebra, is to multiply top and bottom by the denominator. So if I multiply top and bottom by x, then the x's cancel, and what we have left is x over negative 2 plus 3x. And that would be a good answer. Another thing that we could do, how I should put this, or is you go back to this problem right here and you switch from that kind of a divide to the old school divide. 1 has to get divided by negative 2 plus 3x over x. And remember how divide means to flip that upside down? And I think you would get that. So if you like doing the old school divide sign to deal with triple-decker fractions, or you can multiply by the common denominator. All right, let's practice some more fractions here. This time we're going to do g of f of x. So first, write it the nice way. The second thing you do is you write g of, and then instead of the letters f of x, let's put the function 1 over x plus 3. And then we have to put that function into g. So let's go over here to g and let's read what he says. G says negative 2 divided by input. Negative 2 divided by input. Negative 2 divided by input. And my input is the quantity 1 divided by x plus 3. I think this would be a great time to maybe use that old school divide sign. So maybe what I'll do is say negative 2 divided by, and then write that function there. And then we could tell which one we're going to have to flip. So we're going to say divide changes to times. I'm going to flip that upside down, except this is a whole quantity. So when I bring him to the numerator, I have to make sure I use parentheses there. Oops. So that we are very clear that we need to distribute that. Negative 2x minus 6. And this is g of f of x. Okay. So we have some fractions and some flipping to simplify. Okay, what if we have some radicals? Well, the process is the same. Let's just show you a variety of things that might happen so you can be ready for anything. This first example here says f of g of x. So first get it ready. Okay, can you tell what's going to happen next? You're going to write the f and the big parentheses. And what is the g of x function? The g of x function is the quantity 1 minus 2x. And that needs to go into f. So let's go take a look at f and let's read him out loud. The f function says, take the square root of your input minus 2. take the square root of your input minus 2. Okay, what does he say? Take the square root of your input minus 2. I don't know why F has such a deep voice. Okay, the input is the quantity 1 minus 2x. And so I can simplify this radical. Maybe I'll put the negative 2x first. 1 minus 2 is negative 1. Can we cancel anything here or bring anything out? Not really. That's an entire quantity. So f of g of x is just going to be left like that. Okay, looking good. Let's go do a couple over here. G of f. So we're going to be doing g of f of x. Step 2 is to write the g with big parentheses, and then you put the f equation into it, the square root of x minus 2, and that quantity needs to go into g. G says 1 minus 2 times your input. 1 minus 2 times your input. Okay, 1 minus 2 times your input. And the input is the square root of x minus 2. Now, I cannot distribute a 2 or negative into a radical. I think the only way to really write this any differently would be to say 1 minus 2 times the square root of x minus 2. You can't really add these numbers because this is multiply. So that would be the only thing we could do there. G of f of x, putting a function into another function. Okay, let's do some more examples. It's a very important technique here, and we're going to have to get really good at it. Something we're going to be using in the very near future is to show how sometimes they make just an x. Okay, this is a two-part problem. I'm going to do part A first. Show that f of g of x makes an x. I'll do that here. F of g of x. And then part B I'll do over here. Let me just separate my workspace. Okay, f of g. Okay, so f of g. And what's g? G is the function 1/3 times the quantity x plus 4. Okay, and that has to go into the f function. Let's go read f a couple times so we know what to do. F says 3 times your input minus 4. 3 times your input minus 4. Okay, what does he say? He says 3 times your input minus 4. Wow, why is she using such big brackets? Well, because I noticed here that this quantity I got to put as my input has some parentheses, so I thought I would just use a bigger set there. Bigger grouping symbol. Okay, now here's some questions. This is 3 times that times that. So I don't know if we really necessarily need all these different kind of grouping symbols. This is the same thing as saying 3 times 1/3 times that quantity. And then the minus 4 is way over there. So 3 does not have to get distributed to the 4. And it's times, times, times. So you don't distribute with multiplication. Sometimes people think you have to. But if I said, what's 2 times 4 times 5, you wouldn't multiply each of them by 2, would you? No, you would just say 8 times 5 is 40. You would just do multiplication. Okay, 3 times 1/3 cancels out. And then we have x plus 4 minus 4. Okay, don't do too many steps at once. Let's just write a note here. Do one step at a time. Okay, one step at a time. At this point, the plus 4 and minus 4 cancel. And look at that, we did get x, just like they wanted me to show. Okay, so showing means you show every step line by line. Okay, but that was half of it because they also wanted us to show that g of f of x makes an x. Okay, so this says g of, and what is the f function? The f function is 3x minus 4. Okay, that has to go into G. Let's take a look at G so we know what he says. G says 1/3 times the quantity, input plus 4. 1/3 times the quantity, input plus 4. Let me write that down. 1/3 times the quantity, input plus 4. Okay, here's the space for input. And my input is right here, 3x minus 4. The first thing we're going to do is do our work inside of the parentheses. Plus 4 minus 4 cancel. Okay, after you do one step, write down what's left. Do one step at a time. Now the 3 and the 3 cancel, and look at that, equals to x. In the very near future, this is going to mean something. But for right now, we're just practicing all the algebra steps. Okay, let's keep going here. F of g of x. I was looking at some ACT material, and they always put some sort of composing function out, so let's make sure we get this one. We have to do f of g. G is the square root of x minus 2. So what does f say? F says your input has to get squared and then add 2. The f function says your input needs to get squared and then add a 2. Okay, let me get ready. Input has to get squared and then add a 2. And what's our input? The square root of x minus 2. Okay, let's see here. A square root being squared is going to cancel. That gives us x minus 2 plus 2, which equals to x. Oh, nice. That doesn't always happen. The first page of notes, that didn't happen. It's just that sometimes it does. Okay, the next one wants us to calculate g of f of x. So they want us to calculate g of f. What goes into the function this time? The f equation is x squared plus 2. And that has to go into g. Okay, what does g say? G says square root. Okay, let me write that big square root. Input minus 2. Input minus 2. Input minus 2. And what is our input? Our input is this quantity, x squared plus 2. So let me ask you people, is the first thing that's going to happen is the radical canceling with the squared? No, that's not the first thing. The first thing would be for these things. So then you write what's left, and then I can very clearly tell that you did the first thing first, you did the second thing second, and you did it in the right order. If you just start slashing everything at once, I can't tell what happened first and second, and then I don't know if you used the right order, and it's technically wrong. Okay, let's do a couple more here where we have some fractions. Question A is to do f of g of x. F of g of x. Okay, let's see. F of g. G is negative 4 over x. And that has to go into the f function. What does f say? 1 divided by input plus 7. 1 divided by input right there, plus a 7. Some people like to do parentheses, make a spot for it, and then put it in. It doesn't matter. But that 7 could be written as 7 over 1. And how do you add fractions? Some people say they want to flip, but you can't do that first. You have to combine them into one fraction. So let's multiply here by x over x to give him a common denominator. So now I have 1 divided by negative 4 plus 7x with a common denominator of x. And I think I'm going to go old school on this. I'm going to change the divide bar to the divide sign. And I'm even going to change this around a little bit. I'm going to say 7x minus 4. Just looks a little neater when you don't start with the negative. And this one's going to be really easy because 1 times this answer flipped is just going to be x over 7x minus 4. All right, let's do some more fractions here. This time we're going to do g of f of x. So the first thing you do is you write the g, you replace the letters f of x with his function, 1 over x plus 7. Now we have to look at g and do what he says. G says negative 4 divided by input. He says negative 4 divided by input. And the input is 1 over x plus 7. What I'd really like for you guys to do here is somehow clean up this triple decker, and I want to see, I'll check your answer tomorrow when you come to class. So go ahead and pause this video and finish this problem up. Okay, let's take a look at the next one here. These fractions are going to be a little juicier. So first, we have f of g of x. Okay, so we got some juicier fractions. We'll have to pay attention real hard to this one. F of g of x, the g function is x plus 5 over x minus 1. Now, what does the f function say? Wow, the f function has a huge fraction. He says input minus 2 divide by input plus 3. Oh my goodness. Input minus 2 divide by input plus 3. There's 2 places to put the input, so let's get this organized a little bit. I'm going to say input goes there, minus 2. Input goes here, plus 3. And the input, which is this fraction, needs to get replaced twice. X plus 5 over x minus 1. X plus 5 over x minus 1. Now here's a technique I really want you to pay attention to, because there's a hard way and there's an easy way. I'm going to show you the easy way. I'm going to take the numerator and the denominator. What you multiply to the top, you have to multiply to the bottom, so it's fair. And I'm going to multiply by something. Can anyone guess what's going to go in there? And if you're thinking maybe x minus 1, you're right. X minus 1 over x minus 1. So you're going to distribute this to all of the terms. So when this quantity gets distributed over here, the quantity is going to cancel with the quantity. And all we have left is x plus 5. But now I have to distribute it here. Minus 2 times the quantity x minus 1. Well, at least the denominator canceled out. Isn't that the whole point? Trying to get rid of this quadruple decker. Now we're going to do the same thing in the bottom. We're going to distribute it to this first fraction, and that quantity will cancel with the entire quantity, leaving us with just x plus 5. Don't forget to distribute it here, plus 3 times the quantity x minus 1. So we've gone from a quadruple decker to just a regular fraction. All we have to do now is clean this up and we'll be set. X plus 5 minus 2x plus 2 over x plus 5 plus 3x minus 3 is negative x plus 7 over 4x plus 2. And that is f of g of x. So hopefully your composing skills are strong enough here where we could start doing some tough fractions. We got one last example here. Okay, the last one is to do g of f of x. And so, hopefully you know what to do first. Write the g of, you put the f function into the parentheses, which is x minus 2 over x plus 3. Now we have to look at the g function, do what he says. G function is a huge fraction. He says input plus 5 over input minus 1. Okay, let's do that. Input plus 5 over input minus 1. And what's the input? This huge fraction here, x minus 2 over x plus 3. Okay, put that input here. X minus 2 over x plus 3. People that use the parenthesis technique to hold the spot usually do a pretty good job. Just a few less mistakes. Okay, I want to get rid of this quadruple decker. Remember what I said to multiply by to get that denominator out of there? Multiply top and bottom by it. So we distribute times the first fraction. The quantity cancels with the quantity, leaves us with x minus 2. Plus, now we have to distribute it to the 5. So we'll use parentheses there so everything works out. In the denominator, the first time you distribute, the quantity cancels and you just get x minus 2. But the second time, we're going to have negative 1 times that quantity. That same thing happened over here. We had it with the second one, but the first one, it both canceled out. And now we'll just clean this up. X plus 5x is 6x. 15 minus 2 plus 12. Down here, x minus x, nothing. Negative 2 is negative 5. So g of f of x is that fraction. Okay, let's work real hard tomorrow. We're going to practice composing.